Alrighty, so today we're going to be doing determining if lines are going to be parallel, perpendicular, or neither. Alright, so we're going to begin with parallel lines. But no matter what we have going on here, it's really going to come down to the slope. Okay? Parallel lines will have the same exact slope every single time. But first, parallel lines also never intersect. Okay? So we're really looking at, if we graph lines, basically the places that they intersect and cross, that's going to be the solution if we had solved it algebraically. Okay, that x and y coordinate. But if they never intersect, lines never intersect, that means there's going to be no solution. Also, the slopes are going to be the same. Alright, so let's look at an example here of what I'm talking about. Let's say y equals 1/2. 1/2 x, and we'll do -3. Okay, and then we'll do another one, y equals 1/2 x plus 2. Okay, now you guys need to remember that this is in slope-intercept form here. Okay, so remember it's like y equals mx plus b. So the number directly in front of our x, when written like this, is going to be our slope. So both of these slopes are going to be the same here. Alright, so the number all the way in the back is going to be our y-intercept. Alright, so if we go ahead to graph this, remember you want to graph your y-intercept first, so it's going to be -3 here for this little purple guy. So we go down 1, 2, 3. Okay, we call this our y-intercept because remember the one going up and down is our y-axis. The one going left and right here is going to be our x-axis. So basically, we call this the y-intercept because it's where it intercepts the y-axis. My slope here is going to be 1/2, so from this point, I'm going to go up 1 over 2. Remember, slope is rise over run. So I go up 1 over 2, up 1 over 2, over 2. Okay, going this way, I'd go down 1 over 2. And so, down 1 over 2, down 1 over 2. Okay, so your graph should look a little something like that. My red graph here is going to be a y-intercept of 2, so I'm going to start at 2. And I'm going to go up 1 over 2. Up 1 over 2. Okay, I'd go down 1 over 2 this way. Down 1 over 2. There's my x-intercept. Okay, now if you'd drawn this well, okay, these lines would never ever intersect. Doesn't look terrible, I guess, but not that good either. Perpendicular lines. Okay, once again, it's going to come down to the slope. Perpendicular lines intersect at 90 degrees or right angles. Okay, right angle is just going to be 90 degrees. Okay, so it's going to be like a square. Slopes here are what we call opposite reciprocals. I know what you're thinking. What on earth is an opposite reciprocal? Opposite reciprocal. Alright, so when I say opposite, I'm really talking about one is going to be positive, one is going to be negative. Doesn't matter which one's which. Okay, you just need to have one of each for the two numbers to be opposite each other. And then reciprocal would be like fractions just flip. Alright, so we'll look at a couple examples of what opposite reciprocals would be for our slopes. Let's look at that now. So, example of our slopes that are opposite reciprocals. So, we start off with like 2 over 3. Okay, this number is positive, so its opposite reciprocal is going to need to be negative. This was 2 over 3, so really all we're going to do is flip these two numbers and it's become 3 over 2. Okay, so if these were the slopes of two different lines, we would know that those two lines are going to be perpendicular to each other because they're opposite reciprocals for slopes. Okay, another example might be, let's do negative 4 over 3. That sounds good to me. Alright, so this one's negative, so we know that the opposite one is going to have to be positive. Okay, and then 4 over 3 is just going to flip to end up being 3 over 4. Alright, another example might be like, let's look at negative 2. Okay, I know that this number is negative, so my opposite reciprocal must be positive. Okay, but I don't see a fraction, so how would we flip this? So guys, remember you can always write negative 2 as negative 2 over 1. Okay, so now we have it as a fraction. We can just flip it. So it's going to become positive 1 over 2. And then last one right here is really tricky, I think. The number 1. What's the opposite reciprocal of 1? All right, well, this one's positive. That means my opposite reciprocal must be negative. And this is just really 1 over 1. Okay, so if you flip 1 over 1, it's still going to just be 1 over 1. So if we're talking opposite reciprocals of 1, that's going to be negative 1. All right, so let's go ahead and graph two of these. Let's say y equals, what is the same one here? 1/2 x minus 3. Okay, a perpendicular line to this one might be like y equals, so 1 over 2, the opposite reciprocal, we said is going to be negative 2. X, and then we'll just say a plus 1 on the end there. Plus 2, I guess I wrote. Alright, so we've got, let's try to graph this guy. We got negative 3. From here, we're going to go up 1 over 2. I'm going to go up 1 over 2, up 1 over 2. Okay, going this way, I go down 1 over 2. Okay, so my graph should look a little something like that. This purple guy here, we got a y-intercept of 2. So I graph that right there. I'm going to be going down 2 over 1. So remember when you're graphing, you always go to the right. So negative numbers are going to go down to the right. Positive slopes are going to go up to the right. So here we're going to go down 2 over 1. Down 2 over 1. Hey, look at that. This way I can go up 2 over 1. Okay, just play a fun game called Connect the Dots. And there you have your graph. Okay, now the interesting thing about these are perpendicular. Okay, so that is a right angle. So when we draw right angles, you just kind of draw this little square in the corner. It just means it's square, it's 90 degrees. Or you could say that this is going to be 90 degrees, either way. Okay, but basically there are going to be 4 90-degree angles. All right, let's talk about neither real quick here. So guys, understand, if our slopes are the same exact number, then they're going to be parallel. If they're opposite reciprocals, then they're perpendicular. If they're anything else, okay, I mean, basically a negative sign is off, or one small little tiny number, anything, or they could be completely different numbers. Okay, anything else is going to be neither. So if slopes are not parallel or perpendicular, then it's neither one of them. Okay, and honestly, these are going to be most lines that you guys are going to come across. Would be neither parallel, and they're not perpendicular either. That's going to be about it there. I know what you guys are thinking. You really want to do some examples. Let's get some problem solving going. Let's actually do some math. Let's stop talking about it. I guess before I completely erase all this, one thing I want to add here, okay, might appear more on the SAT or something, or some kind of standardized testing. Perpendicular lines, they have a symbol for it. It's going to look like an upside down T. It's going to look something like that. Okay, basically it's really showing here that these are perpendicular to each other. These are right angles. Parallel is going to look like just two lines straight up and down. Sometimes I think it looks like the number 11. Okay, but that really just means parallel. Okay, this would be parallel lines that never intersect. This represents perpendicular. Because books and stuff don't like to write out big words either. They'd rather much rather just use symbols. Alright. Here we go. Alright, so I'm going to put up a bunch of lines here. Basically, the question is, are lines parallel, perpendicular, or neither? So, our first example here is going to be the letter A. Y equals x minus 3. Y equals negative x plus 1. Y equals 2 over 3x minus 4. And then we have 2x minus 3y equals 6. I'll just put 3 of them up here for now. Y plus 3 equals 5 over 4 times x minus 2. And we have y equals 2x minus 3. Alright. So guys, you can pause the video if you want. See if you can answer these questions right now. Basically, are the lines parallel, perpendicular, neither? If you don't have a clue, then just keep rolling here. Alright. Cool, so hopefully you guys gave these a try, figured out if they're parallel, perpendicular, or neither. On my first one, okay? Guys, if we're trying to figure out parallel, perpendicular, neither, it's really going to come down to our slope. Alright? Basically, if our slopes are the same, they're going to be parallel lines, because they'll never intersect. If our slopes are opposite reciprocals, then it's going to be perpendicular. If it's neither one of these, then it's going to be neither. So, you don't necessarily have to do any math on these problems. Okay? I do need to see some kind of reasoning from you. So like this one, if you just said that my slope here, remember is going to be in front of my x, is 1. Here my slope is negative 1. I do know that these are opposite reciprocals. Okay, that was actually one of my examples I gave you for opposite reciprocals. Alright, so my slopes are opposite reciprocals. That just means that these are going to be perpendicular. Alright, and that's all you really need to do. Okay, I'd rather you not just say perpendicular. I'd like you to at least identify your slopes. Okay, kind of showing your work here. But that's really going to be all you need to do. Okay, you're not trying to solve anything. I'm not asking you to solve it. Okay, all I'm saying, are the lines parallel, perpendicular, neither? For B, okay, we're going to identify our slope again. So remember, this is y equals mx plus b right now, which is slope-intercept form. So that means our slope in this first one is going to be 2 over 3. My second one, though, I can't just look at it and figure out what the slope is. Okay, this is what we call like standard form or general form of a line. It's not super useful, so what we want to do is solve for y. Okay, so I can get y by itself. I don't know why I circled the negative 3 with that. If I gotta get the y by itself, I need to get rid of the 2x and the negative 3. So we would subtract 2x first. So I get negative 3y equals 6 minus 2x. Okay, but when I look at that, like, why did I write the x second? Okay, I'm going to write the x first. It really doesn't matter. You guys are just used to seeing it in y equals mx plus b. Okay, so sometimes we get confused. Guys, this would really be the same thing as negative 2x plus 6. My 6 was positive, so it's still positive. My 2x was negative, so it's still negative. It doesn't really matter which order you write them in. but the signs need to stick with the numbers. Then my last step here is divide by -3, so I get y equals. Here we have a negative divided by a negative is going to be a positive. 2 over 3 does not reduce, so I'm going to leave it as 2 over 3 x. Positive 6 divided by -3, well, positive divided by negative is going to be a negative. 6 over 3 is going to be 2. Alright, so my slope here is going to be 2/3. My slope is 2/3 on my first line. My slope is 2/3 on the second line. That means they are going to be parallel lines. Okay? I should be seeing some work. I'd rather you not do that in your head and then list off what your slopes are, and that's all you really need to do for your work. Alright, on C here, the first one I gave you is not in slope-intercept form, but it's in point-slope form. Okay? You guys remember how that works? It's like y minus y1 equals m times x minus x1. So you had a couple different options. You could solve for y and make everything look like this every time. Okay? Or you can just understand that our point here is going to be 2, 3. Okay, but our slope, m, is going to be 5 over 4. So right now, if we're just trying to determine if lines are parallel, perpendicular, or neither, you could just look at this and realize, oh, my slope is 5 over 4. That's all I really care about. Done with that guy. My second one, this is y equals mx plus b. My slope is going to be 2. Okay, so obviously this is not parallel because parallel would be the same exact number for our slope. These are not the same number. The opposite reciprocal of 5 over 4 would be negative 4 over 5. Okay, that's not 2. Or if you look at 2, the opposite reciprocal of 2 is going to be negative 1 over 2, and that's not negative 1 over 2. So this one is going to be neither. Guys, make sure you're circling your answers. That was fun. There's 3 problems. I want to do 4 more with you. Okay, because they're going to get hard. Or harder, I don't know. Alright. So I'm going to write 4 problems on the board. I want you guys definitely now to try to see if you can figure out if they're parallel, perpendicular, or neither. Maybe C, D. 4x plus 3y equals the 9. Y minus 1 equals 2 over 3x. Y equals 2. X equals 4. Y equals negative 3, parentheses, x plus 2. And here we got 15x minus 5y equals 20. And gee whiz, we're having fun on our last one here. We got x equals 3 and x equals negative 1/3. Okay, so guys, like I said, pause the video, work through these 4 problems, and then come back and see if you got it right. And I'll walk you through how to do each one. Alright, so like I said, we need to figure out our slopes. So if I'm looking at this first one, I need to solve for y, so I got to get rid of my 4x first. So I've got 3y equals negative 4x plus 9, at which point I'm just going to divide both sides by 3. So I get y equals negative 4 over 3 x, and then 9 divided by 3 is going to be 3. So here, on my first one, I have a slope of negative 4/3. Okay, on my second one here, this is already in point slope form. If you guys looked at this and recognized my slope would be 2/3, that's great. Because there's really a parenthesis here plus 0. Okay, so that would be y minus y1 equals m times x minus x1. The other thing you could do, in theory, you could just look at this and know that my slope is going to be 2 over 3 because all I would do is add 1 to both sides, and now I'm sitting at y equals 2 over 3x plus 1. So now it's in slope-intercept form where my slope is 2 over 3. Okay? So these are not parallel lines because our slopes are not the same. They're also not opposite reciprocals, right? So 2 over 3 here, the opposite reciprocal is going to be negative 3 over 2. Negative 4 over 3, the opposite reciprocal will be positive. Okay, flipped is going to be 3 over 4. Okay, so these are not the same, they're not opposite reciprocals, so we're going to say neither. Our next one, it's a doozy, okay? It's been a while since we talked about this, but if you just have y equals a number, what that's going to be is a horizontal line. Okay, it's going to be a horizontal line at y equals 2, so we go up 2. There you go. On this x equals 4, if you just have x equals a number, it's going to be a vertical line. So a vertical line at 1 and 2 and 3 and 4. Okay, so if you have a vertical line and a horizontal line, all vertical and horizontal lines will be perpendicular to each other. Okay, the answer to this problem, if you're actually to find the answer, is going to be the point 4, 2. Where x equals 4 and y equals 2, okay, that's where they're actually going to cross. But that's not what we're asking. We're asking, are they parallel, perpendicular, or neither? This would be perpendicular. Okay, so show some kind of work there that you know that they're going to be perpendicular to each other. Don't just say perpendicular. Okay, explain your reasoning. Over here on F, which is hopefully not what your grade is right now. Yeah, I'm talking to you. Alright, this is in point slope form. Okay, this is really y minus 0. Okay, so my point would be negative 2 comma 0. My slope is negative 3. All we really care about is my slope being negative 3. Okay, if you guys are having a hard time seeing that, you can always go ahead and solve for y. It's just a little bit more work. I could distribute here. And I get y equals negative 3x. Negative 3 times 2 is going to be negative 6. My slope is still negative 3. My y-intercept would be negative 6. Cool, cool. All right, let's do this one then. We got to solve for y, right? So when I'm solving for y, I'm going to subtract 15x. So negative 5y equals negative 15x plus 20. I'm then going to divide by negative 5. Negative divided by negative makes positive. 15 divided by 5 is 3x. Here I got a positive 20 divided by negative 5, so it's going to be negative. 20 over 5 is 4. Okay, so here my slope is 3. So we have 3 and negative 3. They're not the same. One is positive, one is negative, so they're not parallel. They're also not opposite reciprocals. Okay? If I look at negative 3 here, that's really negative 3 over 1. So the opposite reciprocal is going to be positive 1 over 3. That's not positive 1 over 3. Also, if I look at 3, the opposite reciprocal of 3 is going to be negative 1/3. Okay, so this is going to be, once again, neither. Which brings us to the last one. Okay, we said x equals a number is always going to be a vertical line. We have x equals 3 and we have x equals negative 1/3. If I were to graph these, I'll sketch a little graph here. Okay, x equals 3, 1, 2, 3 is going to be a vertical line at 3. X equals negative 1/3 is going to be another vertical line at negative 1/3. Okay, so if you have two vertical lines, they're going to be parallel to each other. All vertical lines are parallel to each other. all horizontal lines are going to be parallel to each other. They're never going to cross. So these are going to be parallel. And then we're all done. Sweet. Hopefully that helped a little bit. Take care.